We're solving problem 22 from the AMC 10A from 2019. Real numbers between 0 and 1 inclusive are chosen in the following manner. A fair coin is flipped. If it lands heads, then it is flipped again and the chosen number is 0 if the second flip is heads and 1 if the second flip is tails. On the other hand, if the first coin flip is tails, then the number is chosen uniformly at random from the closed interval 0, 1. Two random numbers x and y are chosen independently in this manner. What is the probability that the absolute value of x minus y is greater than 1/2? Well, you're already on the board. So basically, a coin is flipped. If it lands heads the first time, it is flipped again and chosen 0 if the second flip is heads and 1 if the second flip is tails. If it's tails the first time, then it's randomly chosen. So, from deductive reasoning, we have 4 cases possible in the 2 coin flips. So, case 1. So x is either 0 or 1, and y is either 0 or 1, or case 2. X is still 0 or 1, and y is in the interval 0 to 1. Okay, case 3, and you might already see how this will work. X is in the interval of 0 and 1, while y is in the interval between 0 and 1. It could be 1 or 0. And then our final case, case 4, is where x is in the interval 0, 1, and y is 0 or 1. Now, all of these have a 1/4 chance of happening because you're flipping 2 coins. So, 1/4, 1/4, 1/4. They both have a 1/4 chance of happening. Now, the chance for success on case 1, it's only 1 minus 0. That's the only way, because it's only 0 or 1. 1 minus 0 or 0 minus 1. Since there are 2 ways to do this, but 1/4 probability, this is 1/2 chance rate for success. So case 2, let's look into it. So x is 0, 0, 1, y is 0 and 1. This means that, well, there's one case in this second case where you have to either have 1 minus a number that's in the interval of including, well, you include 0, but don't include 1/2 since it has to be greater than 1/2. So you therefore have to subtract less. So you have to, don't include 1/2, sorry. You either do this, or what you could do is you want it to be 0 minus, so for case 2, you could do that. Or what you could do is, so since you have to make it greater than 1/2, but there's an absolute value. So that means x minus y can be less than 1/2. This is when it's greater. How about when it's less or negative? You could do 0 minus this interval, but if you have to do that, then that means it's going to be in the interval not including 1/2 minus all the way to 1. So it's going to be like that. So that's the only 2 possible ways, and there's going to be 1/2 chance here for success. And there's also going to be a 1/2 here chance for success at case 4. So Now we have to consider case 3. This is an interesting thing because it's either you want it to be sort of, so this is weird and it's hard to visualize, but what we can do is we can graph this. We can graph the number of successes for, well, not successes, but we can essentially graph it. Use visualization. So we make a box with x and y coordinates ending at 1. Like so. You just make this box. And so here's 1/2 in the box. So x and y values start to work after 1/2 since you want it greater than 1/2. Since this is going to work, x is greater than 1/2. It keeps going like this, like a line, until it hits that 1/2 there. Because when x is 1, y has to be, well, it has to be less. And y tends to do the same thing, going up like that. And what we can do is we can find this shaded area, sort of, to get our probability. Since this is 2 triangles that they're identical, so they make a square. That's going to be 1/2 times 1/2 is 1/4, so 1/4 probability in succeeding. What we can do is multiply 1/4 by all these numbers. So this is basically 3 times 1/4 times 1/2, since there's 3 of them, plus 1/4 times 1/4. This is going to be 3/8 plus 1/16. That's going to be 3/16 plus 1/16. 7/16 is going to be our final answer for this problem.